Greetings, this is the man who pretends to be Charles Darwin. What have we here? It is a soroban, which is the Japanese version of the abacus. And when I got this in 1973, it came with a guidebook, Your Best Guide on Soroban, What Brings Comfort and Convenience on Your Life. And the Japanese, this is primarily used in small shops instead of adding machines or instead of cash registers and things like that. And so they were really fast on these things. It was amazing to watch them. I'm rather slow on it. And this is how it works. Take this digit right here, 1, 2, 3, 4, moving up toward the bar. And then for 5, take away the 4, and you move the 5 chip. Okay, 6, 7, 8, 9, and then to go to 10, you have to raise up 1 and put these down. Okay, so now it's 10. And then you go 11, 12, 13, 14, etc. Okay, I'm going to try to add two numbers together, 15 and 17. And in my mind, I already know it's 32. Let's see if I can do it here on the abacus. Okay, so for 15, let me start with 17 actually. Okay, here's 10, and then 2 and 5. Now I'm going to add 15. So I add 10 and I add 5. So here I'm adding a 10, and then to add 5, how do I do that? Well, the only way I can do it is by adding 10 and subtracting 5. And there it is, 32. How about that? That's pretty amazing. Well, they could work really fast with these things. A lot of calculations in previous years were done by hand. For instance, Henrietta Swan Leavitt was a calculator who worked with Edwin Hubble. And what she did was some of the most important calculations in the history of science were done by hand on, I assume, paper. And so by that time, however, there were also mechanical adding devices, and later these were adding machines. And adding machines had rolls of paper. Remember this? Maybe you don't. Anyway, this is a roll of paper from an adding machine. And then later came electronic calculators. This is a vintage 1988 electronic calculator, and it's advanced enough that you can do not just the basic functions, but you can do exponents, and you can do even statistical analysis on it of the simple kind. You can get sum of x squared, sum of y squared, sum of xy, and some of the other things you need in order to do an analysis of variance table by hand. Okay, so that's the electronic calculator. And then you don't need any of those things anymore because it's all on your phone. Okay, now this looked pretty simplistic on the phone. And I thought, well, you can only do just a few basic processes on this phone. And then one day I happened to turn it sideways, and all of a sudden, all of these other things, such as square root, cube root, the Wythe root, and log 10, and things like that, showed up. And so I thought that it was pretty primitive, but it turns out that I just had to turn it on its side. But despite all of this power, of course, now you can have computers that do things almost instantly, that used to take hours. Things that would have taken Henrietta Swan Leavitt weeks to do can now be done in a tenth of a second or less on a computer. But one thing has not changed. You have to know how to calculate. You have to know what numbers to put in and what to do with them. And that is still limited by the human mind. And as a matter of fact, it may have gotten worse because people just rely on computers to give them the answers for everything. And so as a result, when I teach my students, I tell them calculate a percent change. And they can't do it. It's really easy to do on a calculator, but they don't know what numbers to do what with. And so I say, well, think of it as being like retail. Okay, if you have it for $1 and then you do a 10% markup, it's $1.10, right? So going from $1 to $1.10, what percent markup is that? And they'll think, 110? No. And so if you have it for $1 and you sell it for 90 cents, what percent markdown is that? The correct answer is it's a 10% markdown, but they say 90? So I say, look, if you take my course, at least you should be able to get a job in retail after you finish your degree, but it sounded like they were not headed very quickly in that direction. I even had one student one time, granted this is one out of just thousands of students, but I had one student who did not know how to calculate an average. So you have to know what to do. And when you rely completely on rapid computers, then your brain becomes kind of lazy and you don't really know what to do to calculate your answer. Now, the last point I want to leave you with is notice this line on the roll of paper. The roll of paper represents the age of the Earth. That line represents the length of time of civilization. And if you think of the length of time of a single human lifetime, it would be invisible on here. I didn't try to draw it on here. But during a single lifetime, mine, and I'm not really Charles Darwin, so I'm not 200 years old, but during a single lifetime, we've gone from this sort of thing and mechanical calculators to electronic calculators, finally to cell phones and the most rapid computers. And that's all been within one lifetime. That means that technology is changing far, far, far faster than evolution can possibly improve on the human brain, if there is any improvement that is yet possible. If it requires a bigger brain, there's no space for it. So, I don't know. But the point is that we can't rely on evolution to make us smarter. We have to rely on technology. But even that is getting ahead of some of our basic ability of thought. This is the man who pretends to be Charles Darwin. Tally ho, and amen.